So how do we solve humanity's biggest problems? Climate change, poverty, resource scarcity? We've tried treaties, new technologies, and political movements, but probably not. Most experts are now looking up, not around, for the answer. They agree that the most likely way for humanity to take its next giant leap is by reaching for the stars. And today, we're looking at the ultra-competitive, high-stakes race to build an industry that could be worth trillions. A race where entrepreneurs and space agencies are making billion-dollar bets to capture treasures from the heavens. A market that could supply humanity with near-limitless resources, from precious metals to water itself. But as we venture into this final frontier, we'll also be asking how it affects you. Have you ever wondered what would happen if the resources we rely on, from the rare earth metals in your phone to the gasoline in your car, simply ran out? Or if the cost of everything you own suddenly skyrocketed because the materials to make them became impossibly scarce? As our global population grows and our demand for resources becomes more and more insatiable, have you ever stopped to think of the risks? I will warn you now, your life will probably be better if you don't watch this video. Sometimes ignorance is bliss, and you'll be happier not knowing the precarious balance our entire global economy is built on. Because once we open this cosmic vault, there's no going back. I hardly ever thought about where the stuff I own actually comes from. I used to just assume that the metals in my laptop, the platinum in my car's catalytic converter, would always be there, pulled from a mine somewhere on Earth. I'd always think, why worry about running out? We've always found more. If you can relate, then by the end of this video, I guarantee you'll have changed your mind about the ground beneath your feet. But let's start at the beginning. There are all kinds of markets that define our world, from oil and gas to tech and finance. There will always be a demand for the next big thing. What if the next trillion-dollar industry isn't in Silicon Valley, but orbiting above us? Picture humanity's future, powered by an endless supply of cosmic gold and platinum, radically transforming our economies and ending scarcity as we know it. This isn't science fiction. This is the very real promise of asteroid mining. It sounds like something out of a blockbuster movie. Giant robotic spacecraft latching onto asteroids, hurtling through space, drilling into their core, and bringing back riches beyond imagination. And while the technology is still in its infancy, the concept is grounded in solid science, and even more solid economics. Our planet, for all its abundance, has a finite supply of critical resources. Think about the rare earth elements essential for your smartphone, your electric car, and advanced medical equipment. Elements like neodymium, yttrium, and terbium. On Earth, they are incredibly difficult and environmentally damaging to mine. We are depleting these reserves at an alarming rate, and geopolitical tensions often control their supply, creating volatile markets and strategic dependencies. This is where asteroids come in. They are essentially time capsules from the formation of our solar system, pristine remnants packed with the very same elements we're running out of down here. There are millions of asteroids in our solar system, concentrated mainly in the asteroid belt between Mars and Jupiter. But it's the near-Earth asteroids, or NEAs, that have captured the attention of scientists and entrepreneurs. These are the space rocks whose orbits bring them relatively close to our own planet, making them far more accessible targets for missions. They are broadly classified into three types. C-type or carbonaceous asteroids are the most common. They are rich in water, carbon, and organic compounds. S-type or silicaceous asteroids are made of stony materials and nickel iron. And then there's the grand prize, N-type or metallic asteroids. These M-type asteroids are the cosmic treasure chests. They are thought to be the exposed iron-nickel cores of ancient planetesimals, small celestial bodies that were shattered by collisions billions of years ago. Imagine an asteroid just 1 kilometer in diameter. A single M-type asteroid of that size could contain more platinum group metals, like platinum, palladium, and rhodium, than have ever been mined in human history. One particularly famous example is 16 Psyche, a colossal metallic asteroid orbiting in the main belt. It's estimated that the value of the metals within Psyche, if they could be mined and brought to Earth, would be worth something in the order of $10 quintillion. That's a 10 followed by 18 zeros. It has a number so vast, it would completely collapse the global economy if it were all brought back at once. The economic implications are staggering. It's not just about getting rich. It's about a fundamental paradigm shift. A steady supply of platinum could drastically lower the cost of fuel cells, making clean hydrogen energy a widespread reality. An abundance of rare earth elements would mean cheaper, more powerful electronics for everyone. It could democratize technology in ways we can't even fathom. The very concept of a precious metal would be redefined. Gold, platinum, rhodium, their value is largely based on their scarcity here on Earth. If we suddenly had access to a near-infinite supply, their prices would plummet. They might become common industrial materials rather than stores of wealth. This shift would fundamentally reshape global finance and trade. But the potential of asteroid mining goes far beyond just bringing metals back to Earth. The most valuable resource in space might not be gold or platinum, but something we take for granted every day: water. Those C-type asteroids are packed with water ice. In the harsh vacuum of space, water is life. It's not just for drinking. Through a process called electrolysis, you can split water molecules, H2O, into hydrogen and oxygen. Oxygen is breathable air for astronauts. Hydrogen and oxygen are also the primary components of rocket fuel. This means that asteroids could become cosmic gas stations. Imagine a future where spacecraft don't need to launch from Earth with all the fuel they'll ever need. This is a massive constraint right now. Most of our rocket's mass at launch is just fuel to get its other fuel into orbit. But if we could refuel in space at depots supplied by mined asteroid water, the entire dynamic of space exploration would change. Journeys to Mars, to the outer solar system, would become cheaper, more frequent, and more ambitious. We could build and sustain permanent bases on the Moon or Mars, creating a true in-space economy. Asteroids wouldn't just be resources to be brought back to Earth. They would be the building blocks for humanity's expansion into the cosmos. The iron, nickel, and cobalt could be used for 3D printing structures and tools directly in space, a process known as in situ resource utilization. We wouldn't have to launch every single screw and girder from Earth. We could build our future in space, with space. Of course, the challenges are as immense as the rewards. This is, quite literally, rocket science. And then some. First, you have to get there. We need to develop spacecraft that can travel hundreds of millions of kilometers, rendezvous with a fast-moving asteroid, and then either land on it or attach to it. These are not smooth, spherical bodies. They are tumbling, irregularly shaped rocks with very weak gravity. Landing on one is like trying to park a car on a potato that's spinning and flying through the air at 60,000 miles per hour. Once you've attached, you have to mine it. How do you drill or excavate in a near-zero gravity environment? Every action has an equal and opposite reaction. If a drill pushes against the asteroid, it might just push the spacecraft away. New methods are being explored, from robotic arms with scoops to advanced techniques like using concentrated sunlight to heat and fracture the rock. Then there's the problem of getting the resources back. Do you process the ore on the asteroid itself and just bring back the refined metals? This would require a complex, automated, and incredibly durable mobile refinery. Or do you haul the entire asteroid, or at least a large chunk of it, into a stable orbit around the Earth or the Moon for processing? The idea of asteroid wrangling sounds incredible, but the energy and precision required are astronomical. A slight miscalculation could send a multi-ton rock on a collision course with Earth, turning a mission for profit into an extinction-level event. the legal and ethical questions are also a minefield. Who owns an asteroid? The Outer Space Treaty of 1967 states that celestial bodies are not subject to national appropriation, but it's vague on whether private companies can extract and own resources from them. Countries like the United States and Luxembourg have passed national laws granting their citizens rights to resources they mine in space, creating a kind of finders-keepers legal framework. But without international consensus, we could be looking at a cosmic gold rush with no sheriff, leading to conflict and competition in orbit. Despite these hurdles, the race has already begun. Space agencies are leading the way with reconnaissance missions. Japan's Hayabusa 2 mission successfully collected samples from the asteroid Ryugu and returned them to Earth. NASA's OSIRIS-REx mission did the same with the asteroid Bennu, bringing back a treasure trove of material its scientists are now studying intensely. These missions are crucial for proving the technology and understanding the composition of these asteroids up close. Private companies are also jumping in, backed by visionary billionaires and venture capital. Companies like Astroforge and Transastra are developing the technologies needed for prospecting and extraction. They might seem like long shots now, but so did SpaceX a decade ago. We are standing at the very beginning of a new chapter in human history. The transition from exploration to industrialization in space. It's a high-risk, high-reward game, and the players who succeed will not only become wealthier than any person in history, they will hold the keys to humanity's future. The journey will be long and fraught with peril, but for the first time, we have the ability to reach beyond the limits of our planet and grasp the infinite resources of the cosmos. The age of asteroid mining is coming, and it will change everything.